Welcome to week 2 of craziness and strange schooling. Today we're actually going to jump to chapter 8. We'll do a bunch of stuff in chapter 8, then we'll jump back to chapter 7 for one more section. But in chapter 8, we're going to talk about matrices. That is the plural of the word matrix, just so you know. Some of you have said stuff about seeing matrices on the ACT, so here it is for you all. The definition from the textbook of a matrix: if m and n are positive integers, then an m by n, so that we'll talk about that in a minute, matrix is a rectangular array. Some of you computer sciencey people know the word array. So a matrix is just really a way to organize data. It can be just information. It can be a system of equations that we turn into a matrix or a couple matrices. But a matrix is just a way for us to organize data. Each part of a matrix is called an entry. You don't really need to know about these subscripts. That's just how they're cataloging each entry. They're telling you an m by n matrix has m rows and n columns. So going back to that idea, every matrix has a size, or it's called a dimension. And the dimension of a matrix is determined by the number of rows. Remember, rows go horizontally, and the number of columns. And columns go vertically. So it's in that order. So it's rows first and then columns. So a way to remember that is just think to yourself that matrices are really cool. Rows first and then columns. So in these 4 examples, we'll talk about the dimension of the matrix. Part A, it has 1 row and 1 matrix, so it's a 1 by 1 matrix. I don't think I said that right. Maybe I did. Who knows? Part B has 1 row and then 4 columns, so that's a 1 by 4 matrix. Part C has 2 rows and 2 columns, so it's a 2 by 2. Then part D has 3 rows and 2 columns, so that's a 3 by 2. So we can do a couple different things with matrices. We can add them together. For addition, we can only add matrices if they have the same dimension. Man, my handwriting is terrible. Only add matrices if they have the same dimension. Hope you're all doing okay at home. Joke of the day: what kind of bear has no teeth? I will answer that after example A. So example A, find each sum if possible. So we've got a 2 by 2 and a 2 by 2, so we are allowed to add them together. To add matrices, we just match up the entries. So top left, 4 plus 2 is 6. Bottom left, 2 plus 0 is 2. -1 plus -1 is -2. -3 plus 6 is 3. The answer to what kind of bear has no teeth is a gummy bear. You're welcome. Part B, we've got 3 rows, 2 columns, and 3 rows, 2 columns, so we can add these together as well. We get 0, 0, 0, 0, 0, 0. That wasn't very exciting. And part C, we've got a 3 by 3 and a 2 rows, 3 columns. So for this guy, there is no solution. We cannot add matrices that are different dimensions. Another thing we can do with matrices is something called scalar multiplication. So we just take a matrix and we scale it up or we scale it down by whatever number we're multiplying by. So here we've got A, which is a 3 by 2, B, which is a 3 by 3. It's not super important, but they want us to find 3 times A and then -1 times B and then 2A minus 2B. So for 3A, we just take each entry and multiply it by 3. So that's 12, 0, -9, -3, 12, 24. For negative B, we just take each entry and multiply by -1. So -2, -1, +1, 0, 4, -3, 0, -3, -2. For 2a minus 2b, so multiply the first guy by 2. That's 8, 0, -6, -2, 8, 16. We'll do -2b, and then we'll just add them together. So -4, -2, +2, those are both 0. 8, -6, -6, -4. Okay, so we've done 2a, we've done -2b. Now we need to add them together, which we can't do because they're not the same dimension. We've still got a 3 by 2 and a 3 by 3. So this last guy has no solution. But that's how you add and scalar multiply matrices. In the next one, we'll talk about matrix multiplication.